Good morning, Guruji.
Good morning, people. So let's continue with our chapter on applications of Schrodinger equation. Do you guys have any questions from the topics that we learned last evening or until last evening? No questions, I assume.
सर जो probability density है
हाँ
उसे हम mod psi square बोलते हैं या फिर is it a special case
No,
when
no,
the
no.
wave function is normalized?
No, probability density is not chi square only, and you can write it as a psi star psi.
Okay. And when does it have a denominator? When you are talking about the probability, just the probability of finding a particle.
Probability of finding a particle. So
Yeah.
It depends. So for example, if I want to learn probability that particle exists between A and B. So that would be particle which goes from A to B of psi star psi dx, and the whole upon we will have psi star psi over all threes. Okay, I think I got your point. Right. So this thing that we have learned, this is strictly for normalized.
Yes, a normalized wave function.
Yes, I must be normalized.
Okay, I got it. Thank you.
Any other questions? So last evening we took a question on 15 electrons or 15 boson and 5 spinless fermions. So do you have any questions in that part? I did not complete the calculation, but I hope you did. So let's take another question on that same topic. So suppose we have been given 12 fermions, out of which 3 are electrons and 9 are protons. Okay, and they have given us that lowest energy of electron is E naught, and lowest energy of proton is EP, and they're asking us find the minimum energy of the system. Okay, I've already told you what happens when they give you electron and proton. You cannot count them as 12 fermions together. It's a different system altogether. This is a different system altogether because energy depends on mass. People, we have learned the formula for energy. Energy is n square pi square h square upon 2 ml square. So energy is inversely proportional to mass. Basically, energy is a function of mass. That's what you need to realize. It's a function of mass. And since it's a function of mass, you have to draw two different diagrams altogether for electrons and for protons. People. Okay. So here you have what, for example, let me take a different color. So suppose let's say this is ground state. Okay. And then here you have what, first excited state. Okay. Then ground state. Remember we are talking about. I did not mention 2D field. Let me mention 3D box. Okay. So since it's a 3D box, ground state is 111 people. Here also ground state is 111. Okay. And when you talk about first excited state, then the combinations are, we have a 112 combination, we have a 121 combination, and we have a 211 combination. Correct? 3 proteins in the C people. Here also you can write 111 combination. Here also you can write 121 combination. There also you can write 211 combination. I'm drawing one diagram for electron. I'm drawing one diagram for proton. Both of them will have different energy people because their masses are different. Okay. So the ground state of electron they have clearly mentioned it is E naught. Okay. And the ground state of proton they have mentioned it is EP. Okay. And if you remember, as we go ahead, how does the excited state becomes? N square with 3 times ground state people. This is the excited state. So here, what is n square by the way in this case? 1 square plus 1 square plus 2 square. N square is 4 plus 1 plus 1, which is 6. So for first excited state people, n square is 6. So here you will have n square upon 6. Sorry, n square by 3 E naught, and here you will have n square by 3 EP. Energy. I hope you remember, as excited state increases, energy becomes n square by 3 for 3D, n square by 2 for 2D, and this n square for 1D people. Okay. And n square is 6 here, so 6 by 3 times E naught, which is basically 2 E naught. Here energy becomes 2 E naught, and here what does the energy become? Here it becomes 2 EP. I hope you are with me until here. You can always tell me that the reaction repeat whatever. Okay. So we have 3 electrons. 3 fermions. So 2 fermions will be in the ground state, and 1 fermion will be anywhere in the state. Anywhere. I don't care whether it's at 112, 121, 211, or whether it has downspin, upspin. We don't care. It will be somewhere here. And the point 1. 3 electrons are and we have got 9 protons. Okay. So we have got 2 protons here, 2 protons here, 2 protons here, 2 protons here. But this is not sufficient. Only 8 protons are filled so far. So I need another. So for that we'll have to go to second excited state. Okay. So this is our second excited state. Okay. And what is second excited state by the way? After 1, 2, 1, which becomes
1, 2, 2.
Yes, we have a combination of 1, 2, 2. Then we can have 2, 1, 2, and then we can have 2, 2, 1, 2. Okay. So the value of n square here, the value of n square is 2 square plus 2 square plus 1, which is 9. The value of n square is 9. Okay. So what does the energy become? Energy becomes n square by 3 times EP. So that's 9 by 3 times EP. So that's 3 EP. So here the energy becomes 3 EP. And the 9 proton will be here. 2 protons, 4 protons, 6 protons, 8 protons, 9 protons. Here, that's it. So what is our final answer? The minimum energy of the system is there are 2 electrons in ground state E naught. There is 1 electron in first excited state 2 E naught. Then there are 2 electrons in ground state EP. Then there are 6 protons. Sorry, there are 2 protons in ground state EP. There are 6 protons in first excited state 2 EP people. And then there is 1 proton in third excited state 3 EP. That's it. That's the answer. So our answer becomes 3 E naught plus 6 2s are 12, 15, 17, 17 EP. 3 E naught plus 17 EP. I hope you are with me. Please copy, ask me if you have any questions. Don't hesitate. Do not hesitate whatsoever.
Sir, 4 E naught.
4 E naught? Sorry, absolutely. Any questions? Anyone?
Yes, sir.
Others also, let me know if you're writing or thinking. Okay. And when you write 4 E naught plus 17 EP, you can further write this as, so your final answer would be 4 E naught plus 17 EP. This would be 4 into, what is E naught equal to round state? The round state value in 3D. That's important now. Let's recall. So that was n square pi square h square upon 2 ml square. The value of n square is 3 for round state people, because n square is nx square plus ny square plus nz square. Okay, so that's 1 plus 1 plus 1. So this is actually 3. Okay, so the value of ground state is 3 pi square h square upon 2 ml square. This is for round state. So we can substitute 3 pi square h square upon 2 into mass of electron people L square. And similarly, 17 pi square h square upon, here also we can write 2 into mass of proton L square. So the answer would be, you can take 4, you can take 3 pi square h square. Sorry, small correction. I cannot put bracket. Or if I want to put bracket, then it should be something like this. Here also, 17 into what is energy people, ground state energy? It is 3 pi square h square upon 2 ml square, but this is mass of proton. So what we can do is we can take 3 pi square h square upon 2 L square common. We'll be left with 4 upon mass of electron plus 17 upon mass of proton people. The expanded version of it. Make note. See, these are scoring topics, but you need to be very careful first. Okay. With energy, the value of n square into the TDS question. So, next. Let me try it. Here we go. Let's take a question. So they have given us that there is a 1D box, okay, and the length of x is between L and 0. Okay, they have given us wave function, which is given by 1 upon root of 5a into sine pi x by a plus 2 upon root 5a plus 2 upon root 5a into sine 3 pi x by a. Okay, and they're asking us find the expectation value of energy this time. Okay, so by the way, the 3D box is done. Now we're taking random problem. You can give random problems on 1D, 2D, 3D. So the similar problems that I wanted to take on 1D, 2D, 3D, which includes fermions, spinless fermions, bosons, then mixture of fermions, everything of that is done. Now we're taking just random problems on 1D, 2D, 3D right now. Okay, give heading if you want. Random problems on boxes. Okay. So we want to find expectation value. First of all, you remember the formula for expectation value?
Psi star, integration of psi star, a cap psi.
No, that is when you have, that is when you need operator without using operator. Probability of E1 into energy of E1 plus probability of E2 into energy of E2 plus probability of E3 plus energy of E3, and it goes on. Depending upon how many energy eigenvalues you have. This is how you write expectation value of energy. We wrote this in the previous chapter only in postulates of quantum mechanics, and we had taken a question on this also in the class. Okay. But anyway, no problem. Make a note of this very nicely and save it somewhere nicely, because on this also there will be good questions. For example, yesterday also when that jump problem was asked, the 40th question, one of the options where they had asked expectation value. This is how we calculate it. Okay. So anyway, but for that we need to find individual probabilities also. So first of all, we need to convert this in the form that we are aware. People, 1D box. How does 1D box look like? What is the wave function in 1D box? So any sine n is given by root of 2 by L. I'm writing a because they have written a. I make it here because they mentioned a here. So root of 2 by L sine n by x by. Okay, people, I have got 1 here, so this has to be psi 1 related stuff. I have got 3 here, this has to be psi 3 related stuff. Sine 1 by x by a, so that's your ground state. Sine 3 by x by a, that's your third level of excited state. But for that, I require root of 2 by a outside. So we have to multiply by root of 2 by a and the root of b by 2, so that we end up getting the function that we want. Copy this.
So can you please repeat the last step, that multiplication part?
Sure, I'm coming to that. So we'll solve it. Copy this. So psi of x. It's simple. What I want to do here, I want probability. I want to remember how to calculate probability. For that, we require C1 square information, then C1 square is C2 square, Cn. So we require constants. So I want constants basically. But these are not constants, people. If you are by any chance you are thinking this is constant, this is not a constant. Because this is not in the wave function format yet. You need to express psi as linear combination of, right? You need to express it as linear combination of C1, psi1, C2, psi2, C3, psi3. So you need to bring psi1 here. You need to bring psi3 here, correct? How do I bring psi1 and psi3? Psi is root of 2 by a sine n by x by a. So I have got sine 1 by x by a. But do I have root of 2 by a here? No. Let's multiply and divide by root of 2 by a. Simple. I have got 1 upon root 5a. Okay. So I need root of 2 by a. So I'm going to multiply by root of a by 2. So that anyway gets cancelled. Does it have a effect of calculation? No. Okay. And then I have got sine 1 by x by a. I hope you have it. Then what is the second term? 2 upon root 5a. Okay. Again, I need root of 2 by a. So I'm going to multiply by root of a by 2 and root of 2 by a. Anyway, they get cancelled. Does it have a effect of given stuff, people? No. And this is sine 3 by x by a. So they have given us this thing. In between, what I have done is I multiplied by a by root of a by 2 and root of 2 by a. Here also I have done root of a by 2, root of 2 by a. I hope you understood why. First of all, so here a gets cancelled. We have got 1 upon root 10. Okay. What is this thing? Root of 2 by a sine 1 by x by a. That's psi 1. Correct. Here also, what do we see? A gets cancelled, and we have got 2 upon root 10. We have got 2 upon root 10. Now, have a look. Root of 2 by a sine 3 by x by a. This is psi 3. I hope you have it now. Okay. So this is C1 psi 1 plus C3 psi 3. Now the question is this normalized or not? So let's check. Checking normalization. Checking normalization. Okay. So let's calculate C1 square plus C3 square. Okay. Because I don't have any other term. What is the condition, people? C1 square plus C2 square plus Cn square, that should be 1 for normalization. But obviously, they have only 2 terms, so they together should be 1. But see if they are coming out to be 1 or not. So C1 square, that's 1 by 10. C2 square, that's 4 by 10. So this is 5 by 10, people, which is 1 by 2. So no, it's not equal to 1. It's not normalized. It's not normalized. Copy, please. By the way, I've written C1 square, C3 square. Technically, I hope you remember you're supposed to write C1 star C1 and C3 star C3. See, listen, I need you all to do one thing today, tomorrow, whenever, and that is the chapters that we have done, especially NF2M and POQ1. From that, whatever formulae we have come across, okay, especially the ones we are using in the numericals, forget the whole theory, especially the formulae which we have used throughout the numericals in that particular chapter, make a list of them. I hope you have been anyway maintaining a formula book. If not, it's high time you start maintaining the book. Make a list of all the formulae. Okay, so that there won't be any confusion, because I'm getting a feeling that you're finding it harder to recall these steps at the moment.
Yes, sir.
Okay, so it's only important that you constantly revise this form. Even though we have learned this recently, keep a track of this, please. We have put huge amount of efforts in learning model. Let's make it worth it.
Done, sir.
Sure. So what is probability? People? Probability of having energy even, your probability of energy or of having having wave function psi1, that's c1 square upon c1 square plus c3 square. Or you can write c1 square plus c1 square, c2 square, c3 square, cn square, whatever. Okay. So what is c1 square? That's 1 by 10. What is c3 square? That's 5 by 10. So 10 gets cancelled, we have 1 by 5, which is 0.2. Okay. And probability of e3. There are only two wave functions. I can directly write 1 minus probability of e1. So this would be 1 minus 0.2. Answer would be 0.8. But you can also check. Using the formula. This would be c3 square upon c1 square plus c3 square. What is c3 square? That's 2 by root 10 square. That's 4 by 10. c1 square plus c3 square. That's 5 by 10. 10 gets cancelled, 4 by 5, 0.8 anyway. So getting 0.8 either way. This also tricky because there are only two energies. We don't have more energies. The sum of both should be 1. Make a note.
So can you go to the previous slide?
Sure. Since we have taken this question, you can also do one thing today itself then. Try calculating average energy of that 40th question of 2021 paper. Get that one part done. Okay. Done. Next. So we want to find average energy, and we are done. What is average energy? That's probability of E1 into energy of E1 plus probability of E3 into energy of E3. We only have two values. Huh? You can write E2, E4, E5, but they don't exist. So anyway, probability of E1 is 0.2. Energy of E1 in Mandi box people. So that's 1 square pi square x square upon 2 ml square in Mandi box. Huh? And then 0.8 in Mandi box again. Energy of E3 that's 3 square pi square x square upon 2 ml square. The beautiful part about Mandi box and 3D boxes people, the n there is quantum number. Just in 2D and 3D, the problem is that n is not a quantum number. But in Mandi box, the best part is n is a quantum number, n is a quantum number. So you can just write 1 has 1 square and 3 has 3 square. But in 2D, 3D, decided we don't have that option. Okay? So our answer becomes you can take pi square x square upon 2 ml square common. Okay, you're left with 0.2 into 1 plus 0.8 into 9. 3 square is 9. So this is pi square x square upon 2 ml square into 0.2 plus 8 9s are 72. So 0.8 into 9, that's 7.2. 7.2 and 0.2, that's 7.4. So your answer is 7.4 pi square x square upon 2 ml square, which I can further write it as 3.7 pi square x square upon ml square. And suppose if it was so good in any equation, I would have made it. And the answer is n times pi square x square upon ml square, where the value of n is, So n would have become 3.7. Something like that. Could have been, or it could be just a simple MCQ. So that's our answer. Ask me if you have any questions, don't hesitate.
Sir.
बोलो.
सर कल वाला क्वेश्चन है ना, मैंने आज लेट ज्वाइन किया सर.
नहीं कल वाला नहीं है, we have started taking random problems. कोई ना वीडियो लेक्चर देखेगा दोनों सॉल्व कर.
ओके सर.
बोलो.
सर मैंने कल क्वेश्चन चेक किया तो वो ना एवरेज p से निकाला है, p से p = p² / 2n वो फॉर्मूला यूज करके.
आई डोंट, आई एम नॉट कैचिंग. कौन सा क्वेश्चन क्या बोल रहे हो?
सर कल जो
अच्छा वो 2021 का पेपर. हां उसमें
वो उसमें एवरेज एनर्जी निकालने के बाद चाहिए एवरेज मोमेंटम मतलब एक्सपेक्टेशन वैल्यू ऑफ मोमेंटम भी = p² / 2n यूज करके निकाला.
हां आउटस्टैंडिंग. दैट्स ऑब्वियसली ब्यूटीफुल, लॉजिकल, परफेक्ट. So that's absolutely fine. But provided उसमें potential is free. Was it a 1D box? I don't remember. 1D or any of the box. Was it a box problem? 1D, 2D, 3D? Because potential should be 0. I cannot write energy p square upon 2m unless until I know that potential is 0. This is absolutely logical. We have used this too in somewhere, I think during Heisenberg's uncertainty or somewhere. We use this, but this is valid as far as about this potential. Potential is 0, and it could be 0 only.
Square value.
Square value. Square value.
1D box.
1D box. So in 1D box potential is free in between. So yes, absolutely. So you can use this now. चलेगा.
Okay sir.
But from this you will get average value of it's p square upon 2m. So average value of p the whole square. They must have done that. Okay.
Yes,
average of p
sir.
square.
Yes sir. Average value of p square.
Average of p square, no? But then how do we
whole square?
Average of p the whole square. But even after that, you will have to calculate average of p square. Then formula.
सर मैंने वही चेक किया मतलब p कैसे कैलकुलेट करना है तो वो गूगल में भी डायरेक्ट दिखा रहा है कि 1D बॉक्स के लिए वो 0 होगा मोमेंटम.
No, but they are showing it now. We have not highlighted it yet. We will have to check. But yeah, we'll do the calculation.
वही मैंने हां.
No problem. Complete the calculation later. चलो later. Next, done people. Next writing.
सर 2D और 3D बॉक्स पोटेंशियल वेल नहीं होता, बस 1D बॉक्स ही होता है पोटेंशियल वेल, इनफाइनाइट पोटेंशियल वेल.
No, it's not that. It could be 2D and 3D also, but in that whole problem only x was present. Y and z were not there. It was 1D. So you have to check the variables.
So potential well implies
any box. Yes.
Okay.
Any box. Chalo, next. Infinite potential है condition provided. Infinite potential, not finite. Okay. Suppose people just I have given you a wave function here. 1/2L sine sine 1/2L sine pi x by L and then sine 3 pi y by L plus 1/3L sine 2 pi x by L into sine 2 pi y by L. I just want us to write this in a linear combination format. So first of all, we need to identify what kind of a function is this, like what kind of a potential value is this, people. So what do you figure out, people? What kind of a potential value is
2D box.
2D. You have got x and y, two variables, people. So it's a 2D box first of all. In 2D box, how do you write a wave function, people? Root of 2y is sin n pi x by L, root of 2y is sin n pi x by L. So that sin n pi by L. So root of 2y and root of 2y becomes 2 by L, people. And then you have got sin nx pi x by L, and then you have got sin ny pi y by L. But I'll write it all in one line. How do you write a wave function in 2D box? In 2D box, sin nx, ny is root of 2y L sin n pi x by L, root of 2y L sin n pi y by L. But root of 2y becomes 2 by L, and then you have got sin n pi x by L, and then you have got sin n pi y by L. Okay. So first of all, we have understood here, this is n y by L. I hope you are with me. Tell me. So the quantum number here is 1, the quantum number here is 3, the quantum number here is 2, the quantum number here is 2. So we have understood the wave function type by the way. Like this is definitely one thing, and this is definitely 2, 2. Nx, ny, nx, ny. But we need the coefficient also. But to get the coefficient, you have to convert this in this wave function format. For that, we require 2 by L outside people. I don't have 2 by L outside. Yes, I've got L. We can use L at least, but I need 2 also. So let's multiply and divide by 2. You've got half. You've got L. You've got L. But you need 2 also. So multiply and divide by 2 people. I hope you understood this. If it becomes too much, then listen. Simple. Keep 1 upon 2 L as it is. What do you want? You want 2 by L. So multiply by L by 2 and get 2 by L. I hope this is fine. Doesn't matter. And then what do we have? We have got sine 1 by x by L. Sine 1 by x by L and sine 3 by y by L. Plus, once again, I got 1 upon 3 L. But again, I want 2 by L. So multiply by L by 2 and multiply by 2 by L. Okay. What do we have? Sine 2 by x by L, sine 2 by y by L. Okay. So finally, what's the answer then? So as we see, L gets cancelled. 1 by 2 into 1 by 2, this is 1 by 4. And this term, 2 by L, sine nx by x by L, sine ny by y by L, this wave function is sine nx and y. Nx is 1, ny is 3. So 1 by 4, sine 1, 3. Similarly, here also L gets cancelled. 1 by 6, again 2 by L, sine nx by x by L, sine ny by y by L. This is side 2 to people. You got 1 by 4, sine 1, 3, and 1 by 6, side 2. I hope you
Sir, 1
understood.
by 2 sin 1 3.
No, 1 by 4, no, because 2 2s are 4.
Sir, ऊपर भी तो
I've got 1 upon 12. No, ये जो 12 है ये पूरा wave function है ना.
Yes,
2
sir,
by
yes,
L,
I got
हाँ, ये पूरा wave function. ठीक है, take it. From here to here, people that whole is a wave function. That is why multiplied and divided. No? ठीक है, this whole is a wave function. Take it. It's okay. You can ask me to repeat if you want. All you need is 2 by L people here. So in order to get 2 by L, I multiply it by L by 2. Now this whole becomes wave function, and this whole becomes wave function.
So what's the question actually? What was the question?
Nothing. I just wanted us to learn basically that how do we, just like in the previous question, in 1D box we converted this given stuff in this linear combination stuff. So how do we convert them in 2D box? So I just created a random question for that. Just converting it into linear combination.
And for checking the normalization condition, I have to square and add this one by
Yes,
4.
absolutely. Here we can do type. Like for example, I can ask you find the probability of finding energy in let's say psi 1 3 state. I can create a question for this. So get normalization first of all if you want. If normalization exists, the answer is just you can say 1 by 4 the whole square. If it doesn't, then it's c1 square upon c1 square plus c2 square. So let's do this one. Let's complete this. Suppose if I ask you find probability of finding the wave function in psi 1 3. Okay, then people.
Yes, sir.
So let's check normalization. People. Checking normalization. So what do we have? c1 square plus c2 square. So this would be 1 by 4 square plus 1 by 6 square. Obviously, it's not normalized, but we will anyway use this. So let's calculate this. So this is 1 by 16 plus 1 by 36. Okay. So this is 36 plus 16 upon 16 into 36. So this is 52 upon 16 into 36. Let's keep it as it is. We want probability of finding the wave function in psi 1 3. So that's the first one. So psi 1 3 is the first one. You can call this c1. You can call this c2. Okay. So c1 is 1 by 4, c2 is 1 by 6. So what will be the probability, people? c1 square upon c1 square plus c2 square. So what is c1 square? 1 by 4 square. And c1 square plus c2 square you already have. That's 52 upon 16 into 36. 1 by 4 square. Okay. That's 16 actually. 16 gets cancelled. Your answer is just 36 by 52. Or you can say this is 18, this is 26, this is 9, this is 13. Answer is 9 by 13. Take your time, understand, and write. Ask me if you have any questions. Here, when you square it 4 square, so 4 square 16 and 16 gets cancelled. And hence I did not do anything here. Only with practice you realize that once you calculate c1 square to c2 square, don't touch it. Don't calculate it further. Whatever answer you get, leave it in there because things will get cancelled. Because it's a ratio problem anyway. So there will be something cancelled all the time. Clear? So this is the probability that the wave function will exist in psi 1 3. And that the second one you can directly write. It will be 4 by 30. Expected, no 1 minus 9 by 30. Because there are only 2 wave functions here. Okay. Or you can use c2 square upon c1 square plus c2 square. Either way, you will get the answer. So if you want, you can also write. So probability that the wave function will exist in the second one is psi 2 2. Psi 2 2. Check using both the methods. Answer should be 4 by 30. Let me know if you have any questions. Done, people? Shall we?
Yes, sir.
Okay, next. So now listen. I'm taking a different problem right now, which is not related to 1D box. Which is not related to 1D 2D 3D box, but on the same idea, people, on the same analogy. Okay. A question on helium ion. Okay. So they have given us wave function, okay, of a helium ion is. It's not 1D 2D 3D box, people, but everything is on the same line. Okay. Psi of r comma t is given by root 3 by 2 into exponential of minus I e1 t upon h cut into psi 1 of x. Okay. And we have got plus half into e raised to, so or exponential of minus I e3t upon h cut into psi 3x. Okay. They have given us ground state energy is E0. Ground state energy is E0. The value of average energy is dash times E0. That's the question. So it's a question on average energy, but using helium ion. So people, it's not 1D 2D 3D box. Okay. So make it x comma because I've written everything in x. So first of all, people, they have given us wave function as a function of time. You realize that every time when we wanted to convert the initial wave function to a time-dependent wave function, what we used to do is to multiply with this vector, e raised to minus e1 t upon h squared, and e raised to minus e2 t upon h squared, e raised to minus e3 t upon h squared. This one was multiple all the time. So the point is, they have given us this, but this is useless to us. It is just to create confusion. You can go back and write what is the wave function at psi of x comma 0. For that, you have to remove this. All that you are going to get is what? Root 3 by 2, okay, psi 1 of x comma 0, okay, and you can say 1 by 2 psi 3 of x comma 0. Basically, you have made it time independent, or If you don't like this fact, then you can just say this is root 3 by 2. Because this is also a function only, no? You can just say, tell me one thing, hang on. What is psi of x comma t? It was e raised to minus I t upon h square into h cap, if you remember, the Hamiltonian operator, into psi of x comma 0. You recall this now. Okay? If you had psi 1, then you had e1, right? If you had psi 2, then you had e2, right? So for example, if you want to write psi 1 of x comma t, if you want to write psi 1 of x comma t, what is this? E raised to minus I t upon h square, e1 psi 1 of x comma 0. I hope you remember this now. And similarly, if you want to write psi 2 of x comma t, how do you write e raised to minus I t upon h square of e2? This is psi 2 of x comma 0. Note this first, one thing. Just note this before we take the question. Recall this. Write this above one. Just note this first. So if you have this, it means it's psi 1 of x comma t. If you have this, it means it's psi 2 of x comma t. Okay. I hope you are with me.
Yes, sir.
So people, now I hope you realize it is the same thing that they have given us. E raised to minus I t upon h square e1 psi 1 of x. E raised to minus I t upon h square of e3 psi 3 of x. So what can I say? This is nothing but psi 1 of x comma t plus 1 by 2 psi 3 of x comma t. First, I hope you understood this part. This is not a part of the question. Solution has already started. Okay? And now we know what to do after this. Now it's a time pass for people. First, you copy this. Okay? A complicated way to give, but at the end, it's a very simple question. But the question is, what is the ground state energy?
Yes, sir.
Sure. So now that we have got this, we know how to calculate average energy. Average energy would be simply probability of E1 into energy of E1 plus probability of E3 into energy of E3. There are only two energies, huh? Okay. But we need individual probabilities. So again, we can first check normalization, people. Check normalization. Okay. This is C1, okay, and this is C3. Okay. So let's check C1 square plus C3 square. So what do we have? Root 3 by 2 square, that's 3 by 4. 1 by 2 square, that's 1 by 4. So this is 4 by 4, which is 1. This is normalized, people. This is normalized. Even if you don't check now, even if you directly use the formula, it is not harmful, people. I mean, if you can always directly use the general formula of probability, C1 square upon C1 square plus C2 square. If it's normalized, denominator will automatically become 1. If it's not normalized, you only have the denominator. So without even checking.
अलग से करने की जरूरत नहीं है ना.
हाँ, basically अलग से, we don't have to check this all the time. You can directly just, check, directly calculate the probability. So people, you can directly say probability of E1. That is actually C1 square upon C1 square plus C2 square. You don't actually have to check normalization all the time, unless required or asked in the question. And we can directly substitute. Okay. See, what I would have done right now is, the thing is, because I already know it's normalized, probability is just C1 square, and because I know it's normalized, probability is just C3 square. When it's normalized, denominator doesn't exist. It becomes 1 basically. Okay. But the point is, we don't need to check this. We can always write this, because if it becomes normalized, it will anyway become 1. So you can directly use the formula also. That's anything. So either use this, you can write is already normalized, or if you want, you can use the general formula. Normalized. Or we can use the general formula C1 square upon C1 square plus C3 square. So that would be, what is C1 square? Root 3 by 2 ka square, people, that's 3 by 4. C1 square plus C3 square is 1. You are getting 3 by 4. And probability of having energy E3. There are only two energies. I can directly write 1 minus 3 by 4, which is 1 by 4. Probabilities we have got. Now the question is about energies. They have given us ground state energy. They have given us that ground state energy is E naught now. Yes. So even is E naught, people. This is ground state. So they have given us ground state. Even is E naught. Can you tell me what will be E3 now? This is given ground state.
9 times E1.
Huh?
9 times E1.
9 times E1. Why 9 times? It's not 1D box. It's not 1D box. That's what. It's not 1D. It's not
9 by 2.
Why 9 by 2? It's not even 2D box. It's not 3D box. It's a helium ion problem. That's what I said. Now I'm taking this problem, but it's not only 2D. It's a helium ion problem. What is helium ion? What is helium ion?
Hydrogen like.
Hydrogen like atom. So what is the energy there? Minus
Minus
13.6 z square upon n square. Z square is also there. Okay. Z
तो
square upon n.
तो 1 हो जाएगा ना सर.
Huh? No, there is not 1. There is 1 for hydrogen. There is 4 for helium. So there is 2 for helium. 8 z 2
Yes sir.
for there is 2 for helium. Okay. But anyway, so I'll just go to the next page. So people, energy for a hydrogen like atom. See, when you write helium ion, you write helium ion. So that's basically He plus, people. It means it has donated 1 electron. He plus means donated 1 electron. Helium is written as 4He2. It has 2 protons and 2 electrons. But people, if it has donated 1 electron, it means when you write He plus, it only has 1 electron now. Only 1 electron. And because it has only 1 electron, it means it's a hydrogen like atom. And because it's a hydrogen like atom, you can simply say that energy of a hydrogen like atom is minus 13.6 upon n square into z square. So this is minus 13.6 upon n square into z. There is 2 people. This is AXZ. AXZ. There is 2 square. Okay. So this is minus 13.6 upon n square. Z square, that's 2 square, which is 4. So energy of this helium is 13.6, 27.2, 54.4 upon n square electron volt people. This is the energy of helium ion. Any questions? Anyone? Please ask.
सर n की वैल्यू यहाँ 3 होगी ना.
For E3 and for
Yes.
E1 it will be 1.
Yes sir. Yes sir.
So what do we have? Energy is minus 54.4 upon n square electron volt. Okay. So the ground state energy would be just minus 54.4 electron volt, and the third excited state energy would be minus 54.4 upon 3 square electron volt. Actually, the thing is we have to write this in terms of E1 only. They have given us the ground state is E0 now. This is given to us actually. Okay. So minus 54.4, that's actually E0 only. Okay. So this is E0 by 9. This minus 54.4 electron volt, that's E0. So this is just the E naught by 9. We have to write it in terms of E naught. So the answer. But the point is, how do we calculate it is what I've taught you. Okay. So this is E naught minus 54.4 electron volt. That's E naught, and in the denominator you have C square, which is 9. So what is E naught? Other is E naught by 9. Substitute. So answer would be probability is 3 by 4, and then you have E naught, and then the probability is 1 by 4, and you have got E naught by 9. So this becomes 3 E naught by 4 plus E naught by 36. Okay, or I can make it 9 E naught. I can make it 9 E naught by 36 plus E naught by 36. So this is 10 E naught by 36, or you can answer this 5 E naught by 18 people. That's the answer. Ask me if you have any questions. Don't hesitate.
सर कैलकुलेशन में गलती कर दी
मैंने गलती कर
Yes
दी?
sir. Yes sir. Yes.
बोलो कहाँ पे?
27 E naught upon 36 आएगा 978
28 है ना
28 आ रहा सर.
कहाँ पे?
वो एलसीएम में आपने गलती कर दी
मैंने ऐसे नहीं किया है. मैंने
सर 9 का मल्टीप्लाई 9 का डिवाइड करके आ जाएगा ना.
हाँ तो मैंने क्या कर दिया?
मैंने तो कर दिया आपने
3 into 9
अच्छा चलो जो भी है फाइनल आंसर क्या है बता दो.
28 by 36
सबको आ गया ये?
यस सर
Yes sir.
चलो ठीक है. I trust you all. This is 14 by 18 E naught in that case. And this is 7 by 9 E naught. I am prone to errors by birth, so no problem. Then let me know if you have any questions, please. Chalo, next question. Now, another thing that you have to take care. I hope people you are following so far, and if you have any questions, please ask. You have to take care of. For example, I am giving you a question here. If 4 non-interacting identical particles, each of mass m, and spin half, are in 1D box of length 3L, and they're asking us lowest possible energy of systems. Lowest possible energy of systems. Okay. So listen. So they have there are 4 non-interacting, okay, identical particles. They could be either fermions or bosons. They can also be your what is it, ideal gas, Maxwell-Boltzmann statistics also. So there also, if you remember, they are non-interacting particles, but they were distinguishable. I told you earlier, if you remember, when it comes to Maxwell-Boltzmann statistics, when you talk about just ideal gases, even though the particles are identical, but they are distinguishable there because they are far apart from each other. Okay, so they are distinguishable. They have not used any of the such words here. But the point is, when you have non-interacting identical particles, you have other possibilities here. It could be ideal gas, okay, it could be bosons, or it could be fermions. It could be anything. The next break was spin half. Now there is only one guy who has spin half. Who is that?
Fermions.
Fermions. So that's it. So this is how we realize that it's a fermion. They have not explicitly mentioned it. Okay, so it's a fermion. Now it's fine. 1D box. Again, many students know they will read 1D, they will end up getting the answer, but you have to take care of one important thing. They have mentioned that the length is 3L, not L. Okay, so when you write energy, people, when you write energy, which is n square, pi square, h square upon 2, don't write 2ml square. People, length is 3L. Purposely they have them. And there will be an option, there will always be an option, you know, in the 4 ABCD, where you will have the answer which you will get after using L square. But they mentioned that the length is 3L, so this is 3L square. So this would become n square, pi square, h square upon 2m into 9L square. So this is n square, pi square, h square upon 18ml square. First of all, I've created the general formula right away before even solving the question. See, I would have done this too. If I'm creating a question, you know, especially on a circle, I will purposely write, I'll give you the diagram, or maybe I'll write it in the theory that this thing is R. Students will usually have a tendency to understand R is radius, but here R is diameter. So the radius would be R by 2. Okay, so many times we just don't want to check your physics. At the same time, we want to see, you know, with what attention you are reading a problem, how much patience you are keeping. Are you skeptical about little things or not? And do you take attention of these things or not? So that is also something teachers usually want to check. Okay, so just take care. Many times even diameter could be written as R, because these are arbitrary notations. They are not standard notations. You can write them whatever you want. Okay. So here they have written length as CL purposely. Now this is the energy that it becomes. Okay. Anyway, after this is time pass, we already know what to do. So it's a 1D box, people. So that's fine. You have a ground state. Okay. And you have a first excited state. And in the ground state, I will have 2 fermions. In the first excited state, I will have 2 fermions. There are 4 fermions, people. Okay. So every like lowest possible energy, you can directly say this is twice 2 are in the ground state and 2 are in the first excited state directly. The best part about 1D box is what? That ground state n is 1, first excited n is 2, second excited n is 3. You can keep on doing that. Here we don't have to worry about the value of nx and y and z and all of it. You can directly write now. So this is 2 into what is E1, people. That would be 1 square pi square x square upon 18 m square. Okay. Upon 18 m square. And similarly, 2 into what is E2, 2 square pi square x square upon 18 m square. Okay. So I can take pi square x square upon 18 m square common. What I will be left with is 2 plus 2 square is 4, 4 2s are 8. Correct. I will taken pi square x square upon 18 m square common. I'm left with 2, and 2 into 2 square, that's 8 basically. 8 plus 2 is 10. The answer is 10 pi square x square upon 18 ml square. Or you can say this is 5 by 9 into pi square x square upon 10 l square. Please copy, ask me if you have any questions, don't hesitate. I'm trying to take as many problems as possible in this topic, people, because short from this alone chapter, 4 to 6 months of questions are expected in exam. The whole chapter of application of solid equation, we are only halfway through this. There is so much more to do.
So photoelectric effect, Compton effect, and this boxes are super short.
Absolutely. Now, like boxes and how many possibilities?
Okay.
And photoelectric or Compton. I don't think they will ask both of them, either of them, photo or Compton. But then from that chapter also, you have a black body radiation, hydrogen atoms. That's there. Shall we done?
Yes.
I'll give you a theory minimum. I will try to do that video by 30th of November, whatever, where I will at least tell you that if at all, especially for those who are lagging behind in the preparation, the minimum topics that must be covered, which I feel as a teacher, if I would have wanted to set a paper, what are the questions I would have at least wanted to ask. So those topics you must cover from all the subjects. Like for example, even from electronics, there has to be a beautiful question on transistor. Most probably voltage divider. Voltage divider is the best comparative to all the others, because others are easy. Voltage divider is the one that gets complicated. So on transistors, there has to be a circuit problem question. And again, from voltage divider would be a good tentative question to ask all the time. So like that, I will give you a theory minimum that you must complete. I'll try to do that. Try to do that, for sure. So proceeding ahead. Let's proceed. Let's take another question. Ask me if you have questions so far. Again, there's a good question here. They have given us a particle is confined. A particle is confined as shown. Okay. And they have given us it has energy. It has energy 3 electron volt. They're asking us the ground state energy. The ground state energy is dash electron volt. A very good question. One of my favorites. Short, small, sweet question, but again, very conceptual as well, because these things we have covered in the theory. First of all, what kind of a box is this?
One dimension.
One dimension.
So that thing we can declare right away. Next, in 1D box also, what kind of an energy state is this?
Three.
Third dimension.
Third energy state. Good. So this is third level. Okay, third level, or you can say second excited state. Take care. Third level or second excited state. Either of them. Okay. So the quantum number in 1D box, what will that be then?
2.
No,
Three.
3. Ground is 1. Second level is 2, and third level is 3. Level is 3, not excited. You don't have to take care of the excited state. So, ground is 1 now. First excited is 2, and second excited is 3. Okay, so n is 3 only. Basically 3 half loops and quantum number is 3. That's it. Okay. So what is energy, people? Energy, like it is n square pi square. Okay. H square upon 2 ml square. Okay. In this, you can always write this as energy as n square. Wait, hang on. So I have something in my mind. I'm thinking whether that will be useful or not. Okay. First, what about the length? It's 3. Length is not 0. Length is 3, 0 to 3. So this becomes n square pi square h square upon 2m into 3 square. Actually, I'm thinking length will be useless here. Without solving it, we are already done with the question.
Because pi square, h square, 2m square, तो वैसे ही not है.
Exactly. So this is just n square, not that's it. Here is n square, not because people, what is ground state? When you talk about ground state, n is 1. So you're still getting pi square, h square upon 2m square. It doesn't matter what is the length here. You can write ls 3a separately. Just keep ls 3a. I don't think that's significant at all here. So en just becomes n square e naught that you already know by the way. And here they have given us that's 3 electron volts. So this is it. N square, which is 3 square e naught. So this is 3 is 9 e naught. E naught is 3 by 9. Short, sweet, smart question, people. 3 by 9, 1 by 3 electron volt, people. Make note. It's only because we have covered theory nice, and I asked you questions here. We get the result.
Then our favorite question.
No, I thought that it would become complicated, but it did not. The only reason is we have covered this so nicely in the theory.
मैंने भी सोचा था बहुत hard होगा, बहुत easy.
What easy? No, because we covered this, So yes, it's easy. LOL. Then people
Yes, sir.
cover this. Okay, chalo, next. Proceeding ahead. And remember, L is 3a here, just in case, I mean, it's not useful at the moment, but yes. So what about wavelength? Just asking. I mean, good MSQ also could be created in this, like just something like this could be given. They can ask you quantum number is 3 in one options, energy of ground state is 1 by 3, wavelength is this, length is this. Small good MSQ can also be created here. What is the wavelength here?
3 lambda by 2.
A by 2.
2a.
2a. 2a.
2a. Because people, this is 1.5 wave, so the length is 1.5 lambda, right? It's 1.5 wave. Okay, 1 wave here and a half wave. So length is 1.5 lambda. So you can write length is 1.5 lambda, which is 3a. So lambda becomes 3a upon 1.5, which is 2a. See? Now it becomes even better question. Okay. Next. Okay. Chalo, proceeding ahead. Next. They have given us that in a 2D infinite square well potential. Okay. There is energy which is given by 16 pi square h square upon m a square, where a is length of side of square. That's right. Degeneracy is. Take your time. Bro. So first of all,
So
people, answer is this one. It's non-degenerate. Okay. So energy people in 2D is just n square by 2 times e naught first of all. Okay. Or you can just write if you want n square pi square h square upon 2 ma square. They mentioned length is a. If they would have mentioned length is something else, then you should have taken care. It would have become interesting if I would have written as 2a is length. Then here you will do nothing. Here you should have substituted 2a the whole square. Okay, I need to note this again. It would become a good question for a paper people. And listen, the question is easy this time. What I'm saying is, if I would have mentioned that for example 2a is length of the square, here you don't have to do anything. But when you write the general formula, there you have to take n square pi square h square upon m into like when you write 2 ml square. So L is 2a actually. So 2a the whole square. And this is how you get energy. But anyway, right now they have given us a is the energy. So compare what do we have? 16 is n square by 2. 16 is n square by 2. Okay. So 32 is n square. So 32 is n square is nx square plus ny square. There is only one combination. There is only one combination which gives you this, that is 4 people, 4 square plus 4 square. No other combination can give you 32. So this is it. Degeneracy is 1 people, it's non-degenerate. Don't say degeneracy is 0. I have told you this already. Non-degenerate would mean degeneracy is 1 fold degenerate. Call it 1 fold degenerate. Okay. So we complete the boxes here, and now we'll start with harmonic oscillator section. Please go ahead. Harmonic oscillators. We don't have much time for this class. We have around 17 minutes. I will start with the energy problems of harmonic oscillators, but we'll at least study the wave functions and everything related to that. It's better if we take energy problems altogether. Please give heading harmonic oscillators. And again, we will take 1D, 2D, 3D, one after another. Okay. So first of all, people, when do you say a function is harmonic? When it's a function of sine or cos. Okay, it should be periodic basically. As far as it's a function of sine or cos, especially in our physics people, we'll call it harmonic immediately. That's one thing. Next, harmonic oscillator idea is similar to that of a pendulum. A pendulum, simple pendulum, that's also harmonic oscillator. A spring mass system, that's also harmonic oscillator. So we can always use the same idea, like when you write linear simple harmonic oscillator, if you want to study about, it's similar to that of simple pendulum people. When you have a pendulum, when you have a bob, okay, all you have to do is you have to displace it, okay, by some displacement x. What will happen? A restoring force will act in the opposite direction, like we know. Obviously, people greater the displacement, stronger the restoring force, and just lesser the displacement, lesser the restoring force. That's very much obvious. So we know that the restoring force is directly proportional to displacement in magnitude. Greater the displacement, greater the restoring, lesser the displacement, lesser the restoring, but they are in opposite direction. And because displacement and restoring force both are vectors, people, you have to use conventions. They are in opposite direction. So when you remove the proportionality, you write constant k. The constant k can be called as force constant. In case of springs, especially you call them spring constant. Because spring also has the same idea. There also you write Fr is minus x, but just the k there is especially called a spring constant. Otherwise, you can call it force constant. So that's also fine. So people Fr upon x, this basically this is minus k, or you can say the magnitude of k. Magnitude of k is Fr upon x. So what will be SI unit? Force is Newton, x is meter. So this is the SI unit of k. Then what about CGS unit? Force is dyne, x is centimeter. So dyne per centimeter, that's the CGS unit. Okay? Copy this much better. And then obviously people in oscillation chapter you have learned that this displacement becomes a function of sine or cos. You write x is a sine omega t plus alpha, where alpha is initial phase. So it becomes a function of sine and hence you call it harmonic oscillator. Shall we next? What about potential energy here? So Fr is minus kx. We have discussed the potential energy of this in one of the chapters, I think work power energy. But still, so how do we write potential energy, people? So potential energy is nothing but negative of, if you remember, f dx. But you have to calculate this from reference position to a position x. This is potential energy at x. We also calculate it from reference to x. Okay, so this is minus of f is minus kx dx. This goes from reference to x. Minus minus becomes plus k. You can throw outside integration of x dx, which goes from reference to x. So this is k into integration of x. That's x squared by 2. This goes from reference to x. How do we choose the reference, people?
Potential should be 0 infinity.
So here, where does the potential become 0?
At the main position.
At x equals to 0. When x is 0, potential becomes 0, people, absolutely. So we will choose reference position to be 0. That's our choice. Okay? We always choose reference position such that the potential energy becomes 0. Potential energy is kx squared by 2 now. So obviously when x will become 0, potential becomes 0. So we are choosing reference position as 0 here. So potential energy would be equal to k into upper minus lower. So x squared by 2 minus 0 squared by 2. And potential energy becomes half kx squared. We discussed this in work power energy too. But still.
Done, sir.
Okay. The thing is, when these particles, electrons, protons, any subatomic particles, they oscillate. We don't understand k there. We know their mass. We can at max find the frequency of the oscillation, but we have no idea about the k. So we need to convert this k in the form of mass and frequency, and that also we have learned that omega square is k by m. Recently also we discussed this. Okay, so m omega square can be written as k. So this is how we can find the value of k for electrons, protons, anybody who by any chance is performing oscillations people in any potential well. Okay, so potential energy, which is half kx square. Okay, this can be written as half what is k? K is m omega square x square. Okay, so this is our potential energy, half m omega square x square. Just a minute. Sure, next. So now let's learn 1D linear harmonic oscillator. Now we have this potential energy is half m omega square x square. M will be the mass of the particular subatomic particle. Omega will be the frequency with which it is oscillating. Okay?
This is for simple harmonic motion, right?
Yes, simple harmonic motion, absolutely. Okay. Next. Now please give heading 1D. 1D is simple harmonic oscillator. 1D SHO, whatever, or you can write linear harmonic oscillator. Linear harmonic oscillator. Okay. Okay. So what is the potential people? Now potential exists half m omega square x square. What about Schrodinger's equation? I have told you we can write it in two fashions. One is minus x squared upon 2m d square upon dx square plus v into psi. This is e psi. This was one way. Another way was directly written that d square psi upon dx square plus 2m upon x square into e minus v psi is 0. Okay. After adjustment, we get this. Copy. But this time v is not 0. In 1D box, in 2D box, in 3D box, everywhere v is 0 people in between and it's infinite on the extremes. But this time v is not 0. Now v has a value people. V is a function of x in fact. This is a time independent Schrodinger equation. Okay. So the Schrodinger equation now becomes d square psi upon dx square plus 2m upon x square into e minus v. What is v? Half m omega square x square into psi. This is 0. And now people solve this. We don't solve this. Okay. So people put mathematicians to solve this because it's a differential equation but of second order people, and at the same time it's a second order differential equation but with a function of x. See, first of all, it's a second order differential equation, but it would have been fine if it was just something like d square psi plus k psi is 0. Then you just get only complementary function. But now you have a function of x2 people. Okay, so it makes it more complicated. You have a particular integral 2, and that particular integral becomes more and more complicated. Eventually, like it has standards. in mathematics, not even in physics, we learn different kind of polynomials, people. Legendary polynomials, Hermite polynomials, Bessel functions. So this linear harmonic oscillator solution is made for that one. It's not for this. However, I'll just give you the final result of it. We don't have to by heart it. Hang on. Okay. So, okay. First of all, the ground state value. Ground state value we can write it directly. Just a second. But first, you can write this is a differential equation. Okay. This is a differential equation of linear harmonic oscillator or 1D harmonic oscillator, whatever. This is a differential equation of linear harmonic oscillator or 1D harmonic oscillator. Okay. Next. So the ground state wave function you have to by heart. I repeat. This one that I'm giving you, ground state, you have to by heart. Any other excited states you don't have to by heart. Okay. So the ground state wave function sin naught of x. Okay. It comes out to be a e raised to minus alpha square x square by 2. That's first thing. And written as you can observe, not written. Listen and listen. As you can observe, I've written ground state as psi naught this time, not psi 1. People everywhere in 1D boxes, ground state was psi 1. For like ground energy was even. But here I have written psi naught purposely. Give it a star mark. I'll explain you. Give it a star mark. Next, what is the value of alpha here? So alpha square, people, alpha square is m omega upon h square. That's alpha square. Okay. So what happens to psi naught? Psi naught would be a e raised to alpha square. What is alpha square? Just m omega upon h square. So you have what m omega upon h square, and you have what x square by 2. How you can say psi naught is basically a e raised to minus of half m omega x square. Why do I feel that should be omega square? Just a second. I'm not sure. Let me check this out. Because I should have energy. So alpha square should be m omega square upon h square, I think, but they have written omega here. Sorry, no. How many find completed? Because I have got x square dimensionally things are fitting. So this is x square 2. I'm cancelling out dimensionally. Can you just check?
सर m ओमेगा स्क्वायर अपने h का स्क्वायर आएगा
Where?
अगर क्वेश्चन में देगा अल्फा स्क्वायर को psi का कांस्टेंट तो मानेंगे डिफरेंशियल इक्वेशन
No. See, the thing is, I have got half m omega x square upon h square. I have it, okay, and we can make this half m omega square x square upon h square into omega. So half m omega square x square, this is energy based, and h square omega, that's also energy, no? H square omega, if you remember, that's also energy. Energy will get cancelled. Perfect. Dimensionally they are fitting. I repeat, how did I confirm that this is correct, people? Half m omega square x square, we just learned its potential energy. Half m omega square x square here. We just learned its potential energy. So SI unit is good. SI unit is good. So I'm just going to make it half m omega square x square. For that I need to multiply by omega. I'm just taking omega square. Now this is energy. SI unit is good. And S square omega, people, this is also good. I hope you remember. What was S square k? Momentum. S square omega. Energy. Okay. You don't remember. S square is like 2 pi. We write 2 pi f. 2 pi by f. I S f. Yeah. S energy. See, anytime in life you get confused, the formula take time. So this is psi naught ground state function by heart. I hope you are getting this. If you are saying what about capital E? You tell me how to find capital.
नॉर्मलाइजेशन करनी
Our favorite part. So let's find A then. Okay. Shall we, people? Let's refresh it. Okay. I hope you understood this, that it is correct. The best way to verify. Chalo, next. So we have got a ground state wave function which is a e raised to minus half m omega x square upon h square. Okay? Minus half m omega, just m omega x square upon h square. Okay. Or you can also write it alpha. Like we can keep it alpha all the time. We can get rid of alpha later also. That's also fine. That's always up to us. I'm thinking, what should we do? Should I keep it alpha right now during the calculation? So I'll keep it alpha temporarily, and I'll just remember alpha square x square. And what was alpha square? We wrote alpha square as m omega upon h square. No? Okay. So let's start with normalization. So what is the condition? Psi star psi dx, that will be 1 over all space. Now the question is, people, this is a 1D harmonic oscillator. It does not have any boundary, unlike potential well boxes. Harmonic oscillator is varied from minus infinity to infinity for x axis, for y axis, for z axis. This is one of the another difference between boxes and harmonic oscillators. So when you say all space, it goes from minus infinity to infinity directly. You get all the possible values. So this is a. What is psi star? Same now. Do I have any complex now? No. So psi star is psi star same. You get psi naught star. You are talking about ground state right now specifically because you can like psi naught psi naught. That's okay. So we have a e raised to minus half alpha square x square into a e raised to minus half alpha square x square. This is what I hope you have it. Tell me now. So this is minus infinity to infinity into a square e raised to minus half alpha square x square minus half alpha square x square. That minus 1 alpha square x square will get this by minus alpha square x square dx. This is what. Any questions, anyone?
नो क्वेश्चन सर
Chalo. Let's do substitution, people. First of all, this is an even function. Since it's an even function, you can make it immediately twice of 0 to infinity, or e raised to minus alpha square x square dx. This is one. Okay. And now we have to do substitution. So let's say alpha square x square is p.
Sir, इसका डायरेक्ट होता 1/2 root pi upon a.
I mean, if you guys have by hearted, then that's good. Has everybody by hearted that, like, is it a standard formula given by 30 volts? Or if I have to gamma, so ask me.
I haven't by hearted it.
No, but we'll go with gamma because that's what I usually do. But those who have had it any standard formula, that's also good, no problem. Okay. So what we can do is we can go with substitution here. Alpha square x square is p, people. Alpha x would be under root t. Okay. Or I can say x is under root t by alpha. What is dx? 1 upon alpha. What is derivative of root t? That's 1 upon 2 root t dt. Dx we have got alpha square x square is t. That also we have got people. What about limits? Our limits going to change. X goes from 0 to infinity. People, when x is 0, t is 0, when x is infinity, t is infinity. Limits remains same. When x is 0, t remains 0. When x is infinity, t remains infinity. Limits won't change. Limits won't change. That's good. Luckily, okay. So our answer would be a square into limits are not going to change. Then what do we have? E raised to minus alpha square x square, that's t. I've just written alpha square x square c. And what is dx? Dx is 1 upon alpha into 1 upon 2 root 3 dt. Now this is a simple gamma function of people. So I can simply say
2a square था ना?
2a square. Acha, हाँ, yes. Yes, we converted this into that even function. Thank you. So we have what? 2a square. And I can show 2 alpha outside. Okay, 0 to infinity, e raised to minus c. People, what is root t? T raised to half. It goes in the numerator. T raised to minus half dt. This is 1. 2 gets cancelled. So a square upon alpha 0 to infinity of e raised to minus c. How can I write t raised to minus half? I can write half minus 1. Half minus 1 is minus half. It's one and the same thing. Dt, this is half. So now this is the gamma function. 0 to infinity of e raised to minus x, x raised to n minus 1 dx as the result gamma n. As the result gamma n, as the result gamma half. If you are not aware of the formula by any chance, it's just that e raised to minus x, x raised to n minus 1 dx. This is just gamma n. So this is gamma half. Gamma half, you have to by heart, that's root pi. Please ask me if you have any questions.
Yes, sir.
Others, let me know if you're not catching up. Next, so what do we have? A square upon alpha root pi. Because under is gamma half, and so this is gamma half. That's nothing but root pi. Whatever is of n minus 1, n is half. So root pi, this is 1. So we have what a square is alpha upon root pi, or you can say a is alpha upon root pi raised to half people. That's your normalization constant. So the ground state wave function which we have written, if you remember, a e raised to minus alpha square x square by 2. So the ground state wave function is alpha upon root pi raised to half e raised to minus alpha square x square by 2. In this, you need to remember that alpha is m omega upon x squared. Okay? And the verified answer. Sure. Just a second, let me verify the answer. Alpha upon root pi raised to half e raised to perfect. Take your time. Let me know if you have any questions. So that's the ground state wave function of any particle in a linear harmonic oscillator. See, not so difficult to derive. Even if you have not by heart the formula, it's a standard procedure people that you follow. You need good practice in this part, but it's a standard procedure. Check even out first, and then just do substitution, get it in this form, and you should be aware that e raised to minus 6, x square minus 1, that's gamma is. Okay. Others have copied this second try. Okay. So the ground state wave function is basically when we write a e raised to minus alpha square x square by 2, or I can also say it is alpha upon root pi, the whole raised to half into e raised to minus alpha square x square by 2, where alpha is m omega upon x squared. Now, so this is the only thing which I have asked you to by heart, okay? The ground state wave function. Apart from it, just for your reference, because you are maintaining a good notebook, I will give you the formula for the higher energy states, for like first excited state, second excited state, but you are never going to use this for example. Never. That's one thing. Secondly, I've not mentioned this before, maybe to you all, that whatever notebooks you have prepared, people, whatever notes you have during your exam preparation, keep them throughout your MSc. Eventually, during your MSc, you all will be giving next GRF, you all will be giving probably GATE. See, whether you want to go for a PhD or if you want to go for a job, entrance exam, you have to give everywhere. You give GATE examination if you want to get into ONGC. You have to give INET examination if you want to get into ISRO or the affiliations of ISRO. But the point is, every company, even if you want to get into the BAR people, BAR Research Center, they also have their own entrance. So even for job, you have to give entrances, and even for PhD, campus placements are there. Outside campus placements I'm talking about. And for PhD also, you anyway give entrances, NET GRF, GATE, JSTI is also still there, GRE, and all of them includes 30 to 50% of chances in PhD. So whatever notes you have maintained, do not give away. Do not give away to anybody. Keep them with you. Later you will regret about it. Okay? So this could be later helpful to you, not now. So sin n people is given by alpha upon 2 raised to n upon n factorial root pi the whole raised to half. Okay, e raised to minus alpha square x square by 2 into people. We have something known as Hermite polynomial here. Now what is that? You don't have to ask me, which you will learn eventually in your MSc or later. This is known as a Hermite polynomial. It will depend on the type of polynomial. That's it. And you can write the value of Hermite polynomial for ground state is 1. You can write that. And like I said, you don't have to buy hard for your job. It's just for your reference, but it's really good book. We can verify, however, we can verify getting around it. So let's click about it. Let's do that. Let's verify. For ground state energy, substitute size 0, alpha 2 into 0, 0 factorial, root 5, x raised to half, e raised to minus alpha square x square by 2, and s 0 of alpha. So what is it? Size 0 is alpha upon anything next to 0, that's 1, 0 factorial, that's 1, root 5, raised to half, e raised to minus alpha square x square by 2. And what is Hermite polynomial for ground state? That's 1. S is alpha upon Hermite polynomial will vary because as the polynomial. For first excited, you have a different value. For second excited, you have a different value. And you can find it on the internet. But you don't have to back up any of this further. Polynomials are not there in example. Legendary question are like different types of polynomials. They are not there in example. It's way beyond our mathematics. Okay. So we'll stop here and we'll continue with energy of harmonic oscillator and we'll also take 2D in the evening at 5. Humility people, thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
सर क्वेश्चन सर हम क्या वेव फंक्शन का डायमेंशन और यूनिट कभी निकाल सकते
Are
हैं
absolutely. Listen, that has been running in my mind. I want to discuss that in the class. Remind me this again in the evening because some students have already left. Wave function का dimension is evident. Like, but 1D का अलग dimension है, 2D का अलग है.
ये सर वो प्रोबेबिलिटी को लेके आता है ना
हाँ, that's it. Not probability directly. Not even probability. Wave function, you know, root of 2 by L. So it is
1D का हाफ आएगा 2D का 1 और 3D का 3/2
हाँ, but yes, denominator में
लेंथ में हां डिनोमिनेटर माइनस आएगा
so that's it. That's your dimension.
ओके सर थैंक यू
चलो, okay people.
Thank you, sir.
Yes, later. Let me finish writing up. I'll end the session.